Okay, in this episode we're going to create an HTTP transform function. I have to admit this is an issue I sort of punted in the book, but I thought I would revisit it here and go into more details. So first, what is a transform function? A transform function is a function that is used in conjunction with an HTTP request that before the HTTP request is called, the transform function is called on the data, specifically the parameters that you're passing as part of that request. And you can set up a transform function globally on the Angular HTTP service object. So that means every call will use the same transform function to pre-process your parameters before making the HTTP call. So in the books, I actually borrowed a transform function which was built to work with PHP. And I just sort of gave a link and mentioned it in passing and didn't really go into details. It was a long bit of code. I didn't want to include it all in the book. So as part of the parameter passing, it was creating objects like you see here at the bottom of the screen. So almost using like an object array notation and it's not JSON. So ColdFusion was having problems with that, and explicitly ColdFusion, the deserialized JSON function, was not taking numbers like this and turning it into JSON objects. So it had trouble with the approach. It wouldn't see num1 and num2 as properties under num object. So I assume this is just a difference between PHP and ColdFusion. I actually avoided this issue in ColdFusion by creating this secondary function, object to, I forget the exact name, actually it's on the other side. The object to JSON string is what I created, and I called it on objects that were embedded in the parameter object before the transform function would even come into call, and that's how I solved it in the book. That's of course not ideal. So CF needed a format like what you see here. It's an actual JSON object as the argument. In essence, you're going to watch me build a new one from scratch that will work perfectly fine with ColdFusion and will deal with objects. And the major problem with our object to JSON string function was it wouldn't be recursive. So I've sort of fixed it in building this code to deal with embedded objects. Okay, gonna start here, creating a new directory, services remote. And in there, I'm going to create the JavaScript file, authentication service. Okay, gonna create an authentication service function, which we will then later turn into a service that can be passed in and out. Yeah, you don't actually need a name here when you're creating functions like that. I just got in the habit of doing it. I have no idea if there's any good or bad things surrounding that. Actually need HTTP, this is using Angular's dependency injection to pass in the HTTP service object that we'll use to make our remote calls. And the first thing we're going to do here, defaults headers.post. I'm going to set the content type. This is actually something that was covered in the book, unlike the transform function, whereas the way Angular sets up their posts and gets by default, the way they set the host headers, for posts explicitly, it's not passing not passing values, parameters you pass in as actual form variables, which was screwing with my backend code. So we just change, oh, whoops. Yeah, we're probably gonna have to come back and visit that at some time. Oh, and this should be an array. I'm looking at my notes. That got rid of the main error. Oh, and it doesn't know this variable and such because I'm using the remote Angular service as opposed to having it all local, so that IntelliJ can't inspect it. I'm pretty sure that's, what's this one? Unterminated statement. We can fix that one easy enough. Okay, we're going to go back to the HTTP function and defaults again, and we're going to create a transform request, and that is going to equal, it's an array, and function transform data. It's going to pass in the data that needs to be transformed, and let's. So, what this function is actually going to do is return Angular, referencing the Angular framework directly, is object data and string data not equal object file param data. So this is basically shorthand for, it's a conditional. So if the data we're trying to transform is an object, but is not basically a file, then we parse it with the param function, which is something we're going to create next. We haven't created that yet. Otherwise, we just return the data. So that's a good start. Let's do this param function. The object, we're going to pass in a separator, wrap in quotes. So the object being passed into this param function is the actual data. Oh, and let me follow the conventions I've been using and name the function instead of having it be completely anonymous, because so object parameter we're passing in is the data that is being processed. Then we have two others which are not defined. So, but we will define them. If not separator equals and var quote if wrap in quotes quote equals so the separator is an equal sign if we're creating what in essence is the query string, and that'll be used to separate name value pairs. But if within this we're calling this recursively to turn an object into a string, we're going to want the separator to be a colon. And then if we're creating a JSON string, we're going to want to wrap the parameter names and the value names inside quotes. If we're creating like sort of a query string and we're not turning an object into JSON, we do not want to wrap it in quotes. So this is what this code and setting defaults does. I'm actually going to add a few more defaults up here. I mean, you'll see how this all comes together. I'm just defining a lot of new variables that we're going to use throughout this. None of them are used yet. So the bulk of this, for name in object, this will loop over all the properties in that data object that was passed into this function, because we're going to want to take every property and process it so that it can be passed. Get the value. And if value instance of object, we're going to do something. Else if value not equals undefined and value not equals null, we're going to do something else. Basically, we're handling two conditions here. If the value is an object, we're going to do something. Otherwise, we're assuming the value is a simple value. And the value must have a value. If it's undefined or null, we're basically ignoring it. But if it's not, we're going to add it in. The condition we're ignoring in this transform function is whether we're trying to pass an array, which we could handle, but we don't actually do that anywhere in the book. So I am punting on that for now and will not implement that. So this is basically creating a query string. Name. And this is where the quote variable comes into play. Plus, oh, no, separator plus quote value. Oops. And quote. We can get that back on the same. So this is what we have here. Query, which is the query string, in essence the final results. And we're quote because we don't know at the time we're writing the code whether we're going to be creating, in essence, the query string, which will be passed as all form parameters, or whether we're transforming a JSON or an object into a JSON string. So that's why we set the quote based on that wrap in quote function. So we're using this encode URI component. Basically, that's conceptually it URL encodes the name to make sure there's no invalid characters. Then quote the separator, which will either be an equal sign or a colon, depending on sort of which mode this param function it is. Another quote, and encode the value, a quote, and then an and sign. What we'll do before we jump into the object, return query dot length query. Oops. 0 query length -1. This code is the actual return value. Basically, it's removing the last ampersand off it before it returns it. We'll do the same thing when we're creating objects, or actually not the same thing, because we'll be removing commas then, but something extremely similar. So let's do object as string. Actually, yeah, that's fine. We can define it here. Nah, I'll move it up. I'll move it up here. So for subname in value, we know the value that we're examining is an object, so we're going to loop over it just like we loop the outer loop. And for each subname in the value, kind of like each name in the object, we're going to process it somehow. Oh, sorry. Oh. we're going to create a new empty object. And we're going to do O subname equals value subname. And then object as string plus equals param O, which is the new object. I'll call in, because if it's an object, we're turning it into a JSON string. And true, which means in this case we want to wrap it in quotes. And we're in JSON, we're creating comma separated name value pairs. So that's what we do here. And we want to wrap it in the curly brackets. No, of course we didn't remove the comma, so actually I'm going to do something very similar here. Except the object as string here has already been encoded. Because rather each element of it individually has been coded and then sort of jammed together, so we don't need to run it through another encoding because that'll just confuse things. And what we didn't do is we didn't remove that last comma. Length greater than 0. And you know, I'm doing the same thing two different ways here with this. Let's make them consistent. Same concept. It's really object is string equals object is string. So that'll remove the last comma. If there is a length, we use a substring to strip off the last character. And substring is just a common string processing function. So I think it's specifying the length. It's the start location and the length that you want. Object is string. And so let's review the code here and look for any mistakes. First thing I notice is I made a typo there. And I actually defined a bunch of variables we didn't use up here. But we use value. And then that ended up being consistent where I actually defined variables. But I'm going to leave that sort of like that got defined, except not at the top, and so did this. So part of the code that I wrote came from that function I linked to, which I then just took and modified. So I'm not seeing anything that's wrong, and that's very good. So I'm sure we'll have a field day with this when it comes to actually running the code later. But for now, let's take a second, go over what actually happens when an HTTP REST request is made and this transform function is in place. So the function will be called up here, and the HTTP is going to be passed into it. We're going to do that when we create the service bit later. Then it's going to go immediately down here, because this is really the first line in that transform function, because the param function is completely different. If it is an object and it's not a file, we call the param function and pass in that data object. Otherwise, we just return the data. And the param function is where the main magic happens. It accepts three separate arguments. The object, which is the data we're processing, the data we're turning into, in essence, a query string or form variables. The separator, and wrap in quotes, which are not defined on the default call. So first thing it does, of any substance is it defines the separator, if it's not already, and it uses wrap-in quotes to determine whether quotes will be added to the output, and it creates this quote variable, which we can just use when we're creating our function. And if it's an empty string, nothing gets added, or if it is a quote, the slash you see here is actually the escape character. It means the value that comes after it, which our quote does not end a string. It is part of the string. And then we get into a loop in the param function. We're looping over the data object that was passed in, and if it's a name, we're examining each value in it, storing that value in the name, and then we're taking the value of the name. So we're looking at two things. We're looking at the name and the values. So once again, everything comes down in essence to name value pairs. If the value is an object, we're looping over that object and processing each element. And we create a new object here. The reason we create a new object is because we want to pass that new object back into the param function recursively, so it has a name and the value, and it can properly create that name value pair that will be used in our object as a JSON string. Then it removes the comma, adds the curly brackets, and creates that query string. Otherwise, if the value that we're examining is a simple value, we just add it on. Using that encode URI component function, which I'm pretty sure that's just a generic JavaScript function and not something that's part of Angular. And then we strip off the last ampersand, meaning there's no more arguments coming after this. I bet we could avoid stripping off that last ampersand and things would still work, but it could depend how we're doing and how we're sending our data. I didn't test it. It returns the final query string, which is what the return from this, which is back to the HTTP object, sending the values. Now, my intent was to always have runnable code at the end of every episode. In this one, we made a bunch of code changes, but we're not actually ready to test it yet because we have to complete the implementation of the login service class and wire that up to the UI. So I'm going to end this here because I felt they were a little long to try to put into one episode already. This is probably the longest one I've recorded to date, but I thought it was nice, important sort of bonus content for you guys. So next up, we're going to finish the implementation of the service method.